In this video, we're going to look at a rate problem very much like the ones on the AP Calculus test. So, faucets are turned on to allow water to flow into a bathtub, but the drain is not closed. The amount of water in the tub in liters is modeled by the continuous function Wt on the interval from 0 to 10, where t is time in minutes. The rate at which water enters the tub is given by that equation. The rate at which water drains from the tub is given by that equation. How much water enters the tub? Well, this idea of how much, we have the rate. Okay, so this f of t is the rate in. Okay, g of t is the rate out. So to know how much goes in, we need to integrate. Okay, so we would integrate from 0 to 10 f of t dt. This would be a calculator question. You would simply use fn int on your calculator. I'm not going to do that in the interest of time. That's how you would do it. Next, for part B, from 0 to 10, what is the average rate? Okay, so we have a rate equation, and we're looking for the average of that equation, okay, the average rate at which it drains out. So what we're going to have to do is we're going to have to do our average value equation. So 1/10 the integral from 0 to 10 of g of t dt. Okay? Make sure you see what equations are being given to you, so that when it says average and you say, well, okay, you have a choice. You're going to do average rate of change, or you're going to do average value. You need to be sure what you were given, because of course in this problem it says what's the average rate. You might be tempted to think it's a slope, but you've actually been given the rate equation. So finding the average of that equation, that's average value. Next, from times 0 to 10, find the times during which the amount of water in the tank is decreasing. Well, let's think about this logically. If this is the rate in and this is the rate out, the amount of water would be decreasing when more water is going out than is going in. So let's just think about the reasoning first before we actually look at this. We're really talking about when g of t, the rate out, is bigger than f of t, the rate in. Okay? Now, I do have a graph of this, and let me quick pull this in so you can see it. This is the graph. The red represents f of t, and the blue represents g of t. So you can see that starting at time 0, we're pumping in more water than is draining out, and that's true all the way up until time 7.431. At that point, more water begins to be drained out than is flowing in. So we can make from 0 to 10, we can make the answer here that it is during that interval that the amount of water is decreasing. Now, finding the time at which the amount of water is at a maximum. Well, there are a couple ways to think about this, I guess. First way is maybe logically with the graph, and you say, well, you know, I started pouring water in right here, and I'm pouring in more water all the way up until 7.431. I'm pouring more water in than I'm draining. So right here must be the maximum, okay? And then I'm draining water out, so there must be less water than at the end of 10 minutes. There must be less water than there was here. That's a very logical way to think about it. The more maybe calculus way to think about it, the AP kind of way to think about it, move that to the side, is to think that the total amount of water can be found by doing the integral from 0 to, I'm just going to put like a little box here, 0 to whenever you want it, of f minus g. Okay? Because, of course, the integral of f tells us how much went in, the integral of g tells us how much went out, so this would tell me how much actual water there is. Well, if I want the maximum amount, okay, remember maximums occur at endpoints or critical points. So you'd say, well, the endpoints of my interval are time 0 and time 10, time 10. And the critical points, well, critical points occur when the derivative is 0. Okay, so critical points. So you think, well, I need the derivative of amount to be 0. Well, a prime, the derivative of amount, well, the derivative of an integral is simply the function. So it's simply f minus g, and we need that to be 0. Well, you think about the logic that we employed here, and we said, well, you're going to have a maximum until or at the point they meet right here. Well, that's where their difference, f minus g, is 0. So the calculus backs up the logic here for sure that the difference is 0. It's at the intersection point. Really, any way you want to think about that will work. Now, to actually justify this, I would think about candidate test. Candidate test, remember, says actually find the amounts. So how I would do that is I would plug these 3 values in to my calculator and do the integral and see which one has the maximum amount of water in the tank. It will end up being the critical point, as it usually does. Okay, on the AP exam, you should be prepared to use each rate individually, as we had to in A and B. In A, we just looked at how much went in, and B, we looked at the average of how much was going out. You should be prepared to use each one individually. You should be prepared to reason with the two together to say, is the total increasing or decreasing, and how do you know? You should always be prepared to find either the maximum or minimum depending on the problem, depending on which rate is bigger to start with. You should always be prepared to find the absolute maximum and justify that by actually coming up with an integral for the total amount. The nice thing about these rate questions is they're fairly predictable. That probably, if there's 4 parts, 3 of the 4 parts are going to be pretty easy to see coming. By that I mean you're going to be asked about to use one of them by itself. You're going to be asked to compare them. You're going to be asked to find the absolute max or min. There might be some other things on there, but for sure getting a lot of points on this is fairly easy with knowing just what we've done here in A through D.